Hello and welcome to pdfsupply.com. Today we're going to be testing an IC693ALG392. This is a high density analog output module that runs either current or voltage output, 0 to 20 milliamp or negative 10 to positive 10 volt DC output. Wanted to point out on the wiring diagram here a couple things. First is that you'll notice I have a power supply on terminals 1 for my positive and 19 for my negative. This is a 24 volt DC power supply. This is not an option. You must have this power supply in order to test this module. Okay, and you can see that it's powered up. The power supply is powered up because we have a user power supply OK LED indicated here. The next thing is that the current is coming from the left hand side. You'll see in channel 1, I channel 1, and this is all the odd number terminals. 3 through 17 are your channels 1 through 8, and your voltage channels are the even terminals on the right hand side. Channel 1 through 8 is terminals 2 through 16. So please note that and where to get the common. I'll go back to that in a minute. So what we're going to talk about is how to test this ALG392 and how to configure it in Proficy Machine Edition. So far I have this in an IC693CHS397 5-slot rack. It's being powered by an IC693 PWR 330 power supply, and the processor is an IC693 CPU 374 Plus for this test. Now on the Proficy Machine Edition side, I've selected a new clean open file for test purpose, and I've opened up my main rack and selected a CHS397 5-slot rack, PWR 330, CPU 374, and in slot number 2, the IC693ALG392. So I've matched what is in Proficy Machine Edition with what you see physically in front of you here. The next step in order to configure this, you want to go to slot number 2, right click and select configure, or you can simply double click on slot number 2, and the ALG392 settings and configuration will pop up, allowing you to change values and such. So the first thing under the tab settings and underneath parameters is active channels, and it always starts with 1 active channel, but we want to test the whole card, so you want to select 8 channels. You do that by either right clicking under value or double clicking under value on the one itself, and a window will pop open which will allow you to change that 1 to an 8, and then you select OK. Another thing to note on this particular page before we go to another tab is the reference address. That's the third setting down. The reference address, since this is a new clean file, the computer has selected %AQ, which is analog output, 0001. And that's where I'm going to start putting my values in the analog output reference table in order to get my readings. Next thing, also in Proficy Machine Edition, is the output channel data. Pardon me. So if you select that, you'll see all your channels 1 through 8, and you'll see whether they're selected for voltage or current. The default setting automatically is 0 to positive 10 volt DC. And if you right click on that and select Data Entry Tool, you'll be able to change each channel to whatever you want. It could be 0 to 10 volt, negative 10 volt to positive 10 volt, 4 to 20 milliamp, or 0 to 20 milliamp, depending on which side that you're testing, as we've shown before on the door scheme. So for this test, I'm just going to go with the default reading, which is 0 to 10 positive 10 volt DC, and all channels are going to be 0 to 10 volt DC. Okay. Now the processor is already in run mode, and now that it is, what I want to do is go down to Reference View Tables and then open up my default tables, and the second selection down is %AQ or analog output. I'm going to double click on that, and my reference table comes up, and the top right hand corner is where it starts analog output 0001. And in there I'm going to put a full value of 32,000, and the result should be positive 10 volts. And what I've also done is put 32,000 in all the other channels, 1 through 8, so that I can go through and test each one. And I'm going to show you what that looks like on a multimeter. I have my 2 leads from my multimeter, positive and negative. My negative goes on 18, voltage common. And I'm going to start from number 2, which is the top terminal, and make my way down. And the voltage reading I'm looking for is 10 volts, or as close to 10 volts as I can possibly get for each channel. All the way through 8. So they're giving me full value, but since this is not a discrete module, this is a analog output module, it has range and resolution, and I want to check that I have full range and resolution of the analog output card. So I'm going to go back to terminal number 1, which again is just about 10 volts, as you can see. And I'm going to take that 32,000 that I initially put into analog output address number 1, and I'm going to cut that in half to 16,000. And what I'm trying to do there is to make sure that I'm getting 5 volts, or very close to it, 4.982 volts. Then I'm going to take that 16,000 and divide that in half, go to 8,000. And I'm looking for 2.5 volts. 2.485, and then I could even go down to 4,000. I'm looking for 1.25 volts, or as close to it as possible, 1.236. So what I'm doing there is I'm making sure that it's not a failed card, because what we normally see is that if a card fails, more often than not, it fails at full value. In other words, no matter what value I put in the output table, it's always going to read 10 volts for some reason. So you want to make sure that you scale down however you see fit to do it. My way is just by doing it 32,000, 16,000, 8,000, and just descending on each channel to make sure that they have their full range of value, since it is an analog output. And I do the exact same thing with the milliamp side. So as far as testing the milliamp side, it's the same exact test that we just did for the voltage. The only difference is you'll have to set your multimeter to read milliamps, and the common in this particular case is the same common as your power supply. So you'll take the common and put it on terminal number 19, and then test all of your corresponding channels from terminal 3, 5, 7, 9, all the way through 17. Another thing that we commonly see with the ALG392 is a problem. There's a couple things actually. The first and easiest one is if you plug the module in and you turn it on and you don't get your OK LED. That's usually a very clear, quick indication that there's a problem with the module, and you normally wouldn't get any response from it. Second thing is if there's something wrong with its ability to accept the 24 volt DC through the user supplied power supply. If this LED isn't on telling you that that's working properly, that's another problem. Third problem is the one that I mentioned before, is where the output fails at full value. And the fourth one that we see is that everything seems to be working properly. You put a value in and you're not getting anything in return on your multimeter, it's just reading 0. So any of those things would be a major or a catastrophic problem with that module, and it's something that we are able to repair here at pdfsupply.com. We offer remanufactured and new products and same-day shipping. So if that's something that you need or interests you, please see us at pdfsupply.com. Thank you.